Hello, I am Ahmed AlKsas. I am a PhD student at Computer Engineering, Computer Science Department. I am also a graduate research assistant at Bioimaging Lab Bioengineering Department, Swedish School of Engineering, University of Louvain. Today, I am going to give you a presentation about my final project at the Artificial Intelligence class with Dr. Roman Yampolsky. My topic is genetic algorithm with wisdom of artificial crowds for Boolean satisfiability problem, or SAT. MB problem stands for the non-deterministic polynomial time. MB problems are series of problems that can be verified using a non-deterministic Turing machine in polynomial time as a function of the given input size. The possible most challenging MB problems class is the MB complete problems. SAT is the first MB complete problem to be proved. It is one of the most significant MB problem in the artificial intelligence domain. It is the issue of evaluating if an interpretation that satisfies a given Boolean formula exists. A Boolean formula or a Boolean expression, consists of variables, operators, and parentheses. The conjunctive normal form or CNF formula, which is a conjunction of clauses, defines this instance. Each clause is a literal disjunction described as a variable f or its negation f dash. The primary objective here is to find the distribution of variables or a combination of variables that satisfy all the clauses and hence the formula. So our final solution is some values for all the variables we are using. These are Boolean variables. We have either true or false, 0 or 1. Then we need to apply these values over all our clauses. So we are searching for a combination of true or false values, substituting these variables in a given formula in such a way that the formula is true. If this combination is possible, or if the combination exists, so the problem is satisfiable. If not, so the problem is unsatisfiable. My main work here is to solve the SAT MB complete problem using a hybrid algorithm combining genetic algorithms with wisdom of artificial crowds. Genetic algorithm is a class of search techniques that use simplified forms of selection, inheritance, and variations. Strictly speaking, we can say that genetic algorithm is not a method of optimization, but it can be used to form the center of a class of robust and usable techniques known as genetic algorithm-based optimizers. On the other hand, wisdom of crowds is a swarm-based meta-heuristic algorithm for optimization inspired by nature. This approach of wisdom of crowds, inspired by human collective intelligence, relies on a group of simulated intelligent agents to arrive at independent solutions aggregated to generate one optimal solution. This solution could outperform the individual solutions of all participating, or at least give performance as good as the best individual among all of them. Here is the framework for my approach. For the inputs, we have 3 CNF formulas. 3 CNF formula, that means a formula having each clause of them, all the clauses consists of just 3 variables. We have any number of variables, but each clause consists of only 3 variables. Then we have some parameters for the approach. Then we can apply genetic algorithm. Then wisdom of crowds over the results we had from the genetic algorithm, and finally evaluate our solution. Here, the evaluation is in terms of the execution time, the total processing time, and the fitness. Here, the fitness is the ratio between the true clauses to the total number of clauses after applying or after substituting our final solution values. So the input here is dataset. My datasets are random ksat 3cnf.dimex files collected from toughsat.appspot.com, and the parameters of the algorithm is fed by the user from the following GUI. we have here a pass to the data set, then the crossover rate, the mutation rate, the size of the population, and the number of generations for the genetic algorithm, number of repetition we do for the wisdom of crowds approach, the threshold, the fitness threshold we are using in our algorithm. Here I'm going to talk about first about the pseudocode I used. First is the initialization. We read the data set of formula, then read the parameters fed by the user. Then for the wisdom of crowds, firstly we initialize the crowd of experts. Then we iterate multiple times over the genetic algorithm. The genetic algorithm starts by initialization of random population. We then sort the population to get the fittest individual at the beginning, generated children with crossover, then mutation, then evaluation. And after evaluation, we iterate and adding the best children or the fittest children to the population. We iterate multiple times to find the best solution among all possible solutions or among all the population. After all of this, of the genetic algorithm process is, we run it multiple times. Now we need to select the experts. Here the selection is based over a threshold fitness. Then after finding our experts or our crowd, we look for the most common chromosomes in the crowds. Here the chromosomes is a part of the solution. Then we use a greedy algorithm to aggregate these selected chromosomes. Then we combine these chromosomes to form the final solution. After having the final solution, which as we said before is a combination of values for all our variables, then we evaluate the final decision according to fitness and execution time. And then we compare it to the unenhanced genetic algorithm. Now let's go for the experimental results. Here I want to run the code in front of you. The code is written in Python. Let's run the code. So we are waiting for, here is the GUI. So let's enter our data set. The first data set was 600 variables and 600 clauses. The crossover rate, let's say 0.1. The mutation rate, 0.01. The size of population, let's say 100. Number of generation, let's do it also 100. Number of repetition of genetic algorithm, let's make it 20. The threshold, 0.9. And finally, number of threads, let's make it 5. And then run the genetic algorithm. Let's wait for the answer. Yeah. We have the answer here. Yeah. Here is, we can see improve the fittest crowd by the unenhanced genetic algorithm. And in red, we can see the final solution fitness. As we can see here, the final solution is much more better than the unenhanced genetic algorithm. Here is the best solution we get by the unenhanced genetic algorithm. And in red, we can see the final solution. Okay, let's go in numerical results. We can see here the worst fitness using the unenhanced genetic algorithm is 0.93. The best individual, we have a fitness of 0.945. We had an average fitness of 0.938. For the wisdom of crowds or the hybrid approach, we have the final solution with fitness of 0.965. We can try another experiment with a larger data set. Let's try something else. Okay, let's try 900 variables by 600 clauses. The crossover 0.1, the mutation rate 0.01, number of generations, we can stick by 100. Number of generations and the population 100. We can repeat for 20 times. And the threshold 0.9. Number of threads 5. We can run the genetic algorithm. Let's wait for the final output. Okay, here we can see our final solution is in red, and in blue we can see the best individual or the fittest individuals we had using the unenhanced genetic algorithm throughout all the generations we had. Here's the best individual using the unenhanced genetic algorithm, and we can see that the final solution is better than it. Okay. So let's get back to more experiments, more results. The first experiment here is 3 variables and 20 clues. We can see that the output here, the final solution, is typically the same. We are having the same fitness as the unenhanced algorithm. But you can see here that the fitness is a little bit low. Keeping in mind we are using here a tiny data set, but the problem here or the cause of this low fitness is because the data here is unbalanced. We have over 20 clues, we have only 3 variables, and we need to have a solution for it. So this is the problem. With a little bit wider data set of 20 variables and 60 clauses, we can see that our approach, the fitness is much higher than the last experiments or the previous experiment. We can see that the approach, the hybrid approach, outperformed the unenhanced genetic algorithm. Here another data set of 60 variables and 100 clauses. We can see here that the genetic algorithm had 2 individuals which are better than our approach, but totally the approach is higher than most of the fittest algorithm or the fittest individuals. Another data set of 100 variables by 600 clauses, and we can see here the approach, the hybrid approach, outperform the unenhanced one. The same for the 800 variables by 600 clauses. And finally, we have 1,000 variables and 1,000 clauses. We can see that our approach had the best solution. So to conclude this, we can see that the final solution is always better than the average answer of crowds. When we have a small number of variables and clauses, the fitness of the crowds and the wisdom of crowds final solution is almost the same. From the first experiment, as we said before, if there is no balance between the variables and the clauses, the fitness value of the crowds and the approach becomes low. When the variables to clauses ratio is balanced, we can see that the fitness of the approach is so good. When the size of the problem becomes very large, the performance of the hybrid approach is still good, given fitness values near the best individual in the crowds and higher than the average fitness of the unenhanced genetic algorithm. To summarize, the hybrid approach can successfully find a solution which is better than most of the solutions given by the standard unenhanced genetic algorithm. Despite the improvements, the optimal solution obtained for larger data sets looks like they are not the global optimal solutions, as sometimes, as we saw, the fitness sometimes comes up a little bit lower than the best individual in the crowds. In the future, I want to find a generalized approach which can work on different MB problems. This algorithm is utilized or manipulated from from a previous project we had in this semester. It was working on the TSP problem. But I need to have a more generalized approach. I need also to make much more experiments, and I need to examine much more combinations of parameters. We can examine wider crowd. We can perform more statistical tests over the results, and the thing that I think would enhance the performance or improve the performance of the approach is to try another aggregation method rather than the greedy algorithm. We can also try some other methods for choosing the experts. That's all I have today. Thank you so much for your time, and I would be more than happy to receive your questions. Thank you. Bye-bye. Bye.